faithfully delivering value and exploring the world's best books. Hi, this is Sally with Book Insights. Today, we're interpreting the book, The Age of Big Data, with the subtitle, A Revolution That Will Transform How We Live, Work, and Think. As everyone knows, the flu virus spreads fast, is super contagious, and a real pain to handle. It often takes countless lives in no time. But for ages, health departments only reacted after outbreaks, starting where cases popped up, isolating patients, and developing vaccines. In short, human actions always seem a step behind the virus. However, in 2009, the world's biggest internet company, Google, did something wild. They predicted a flu outbreak earlier than health departments. How'd they pull that off? Turns out, as the world's top search engine, Google stores years of search records and scoops up 3 billion queries daily. It was exactly these records that made prediction possible. Google's techies sorted all search data from 2003 to 2008 and found that before flu outbreaks, folks often searched for keywords like cough, fever, how to treat, and so on. And in a certain period in 2009, these keywords popped up again in clusters. So they figured another flu wave was coming, and yep, it happened. Seems like predicting is easy peasy, so why didn't anyone do it before? The tricky part is to predict accurately, you need tons of data. And in that area, almost no outfit can match Google. And the tech Google used is what's called big data. But the term big data rings a bell for most of you. From tech papers to national plans, big data is mentioned everywhere. So what exactly is big data? What changes and challenges will its use bring? The book, The Age of Big Data we're covering today, aims to answer these questions. The book's two authors are big deals. One is a scholar named Viktor. Mayer-Schönberger is now a professor at the Oxford Internet Institute. Way back in 2010, he published a batch of articles on big data that shook up the industry. The Economist even hailed him as an authority on big data. Meanwhile, Victor's a big driver in applying big data to business. Tech giants like Microsoft, HP, and IBM have all sought his advice on strategies for the new era. Today, many of Victor's forward-looking insights, especially his predictions about big data uses, have come true, one by one. That's why the industry calls him the prophet of the big data age. The book's other author is Kenneth Cukier, a senior editor at The Economist magazine who's long covered tech innovation, and he's also a hot TED speaker. The book we're covering today is pretty much a must-read for getting a grip on big data. It helps even newbies understand how big data tech will shake up the world. Before we dive into big data's impact, let's chat about its two key features. First, as the name hints, big data means an insane amount of data. Over the past decade or so, with new tech, we've turned out more and more info. Search engines alone handle billions of queries daily. So just how much info is there today? Back in the 3rd century BC, an Egyptian king spent his life gathering all written stuff he could find and built the Library of Alexandria. But today, the data each person on Earth can access equals about 320 of those libraries. Library of Alexandria. As they say, quantity changes quality. This explosive data growth has led to a quantum leap in how we use data. Second, big data's core job is predicting the future. Google using big data to predict the flu, as we mentioned earlier, is one example. Or say, if we could collect data on how fast people cross streets and how often they ignore traffic lights, then use that big data in self-driving cars, it'd know where to slow down and where to speed up. In short, big data experts spot behavioral patterns in massive data to predict what's next. So what kind of changes will this tech bring? Professor Viktor thinks that first, big data will change how people view data. Second, in business, data will become a new source of value, birthing tons of new big data companies. Third, as big data applications deepen, we'll face some troubles and threats in our personal and social lives. First, let's see how people's way of viewing data has changed. Just to clarify, when the author says people, he mainly means data researchers, because big data has directly changed how they work. One obvious change is they now handle massive data instead of isolated samples. What does this mean? When we talk big data, it implies contrast with small data, like random sampling you learned in high school. For example, to check instant noodle safety in a batch, we don't test every pack. Inspectors randomly sample some. If the sample passes, the whole batch is considered good. Another example, telecom companies studying user habits don't call everyone. They survey random users. Based on survey results, they draw conclusions. Small data is a popular research method. It saves time and money. Using partial data gives relatively accurate insights about the whole. If data is random enough, people can confidently use it. In contrast, big data era means no random sampling. We use all data. In small data era, samples were partial data. In big data era, samples are entire data sets. Like Google predicting flu used worldwide search results, not random times or regions. Second, as data volumes grow, researchers must accept fuzziness. In small data era, limited data meant tiny errors could distort conclusions. So people demanded high data precision. But with big data's huge volumes, we can't ensure every data point is absolutely precise. Flip side, with 100,000 data points, even 100 inaccuracies won't seriously impact results. For example, if you want to know if your heart rate is normal, you can get a medical checkup at a hospital using precision equipment. The machines must be highly sensitive, and doctors need full concentration to record reliable data. But wearables like smartwatches offer another option. They track heart rates 24/7. With so much data now, occasional device glitches or inaccurate readings don't affect the overall results. Finally, in the big data era, researchers focus less on causality and more on correlations between things. In small data thinking, if phenomena A and B co-occur frequently, we'd investigate why they're causally linked. Then we'd collect samples to test hypotheses. But big data thinking pulls all data directly. See when A and B co-occur to predict future scenarios. Simply put, small data answers why while big data answers what. Take Walmart, the US retail giant with a massive database. It records not just what customers buy and spend, but purchase dates and even weather conditions. Analyzing this, Walmart found before typhoons, flashlight sales spike, and people buy a specific cake. Why do customers buy cake instead of other foods? Walmart doesn't care why. The correlation itself matters most. So before typhoons, they display that cake with flashlights, dramatically boosting cake sales. To summarize part one, big data is defined relative to small data. Small data uses random sampling for precise data to see autumn from one leaf, revealing causality. Big data handles messier, vaster data sets. Its sample is the entire data set. Despite individual inaccuracies, massive data reveals the big picture and uncovers correlations. If these ways of thinking still sound abstract, big data's impact on business affects every one of us. Professor Viktor notes that as more info gets digitized, data itself becomes a new resource, creating massive business value. While information technology sounds familiar, people usually focus more on the tech, thinking upgrades drive economic growth. It took big data for folks to realize info's high value. Though not all info counts, only digitized info matters. What does that mean? Let's illustrate with an example. Imagine an e-reader. On this device, you read books without physical copies. That's digitizing content. Plus, it records how long you spend on books, time on specific sections, and similar titles read. That's quantifying user behavior. And the result is data. Don't underestimate this data. Its business value is huge. Publishers can improve text using e-reader data. If readers linger on a section, it means they love that content. Publishers then ask authors to cater to these preferences, writing more to boost sales. Conversely, if readers skim sections, publishers tell authors to cut back to avoid hurting sales. Clearly, data has become a commodity, influencing business decisions. But Professor Viktor believes this is just the tip of big data's potential. In business, there are three deeper ways to mine data's value. The first approach is data reuse. Big data's most common tactic. The same data in different contexts serves totally different purposes. Take Walmart's example earlier, a classic case of product sales data. Originally for warehouse management, but recombining it revealed the cake weather link. Another example, Google Maps sends Street View cars to photograph streets and collect location data for accuracy. In this process, it collected massive road surface data. Later, when Google developed self-driving cars, this data proved invaluable again. Why is Google leading in autonomous vehicle development? Well, the answer lies right here. The second approach is data reintegration. Sometimes data only reveals value when combined with other data sets. In 2011, the Danish Cancer Society published findings showing mobile phones don't increase cancer risk, thanks to big data tech. Danes started using mobile phones as early as 1985, generating decades of user records, including usage frequency and duration. Meanwhile, Danish medical institutions maintained complete nationwide cancer patient records. Researchers accessed both datasets from 1990 to 2007 to find connections. They investigated. Do mobile users get cancer more than non-users? Do heavy users have higher cancer rates? Big Data's conclusion, no link between them. Both datasets in this experiment were generated long ago. But to test a medical hypothesis, researchers activated and reintegrated them, yielding new insights. Third, even seemingly useless data can be leveraged. There's an industry term, data exhaust. Digital byproducts like page dwell time, mouse positions, or typos. Companies see these actions clearly in backends, but what use are they? Actually, search engines use data exhaust to optimize results. Sometimes search results show keyword-rich pages that don't deliver what we need. Search engines must prevent this. Without big data, staff would manually check each link's relevance. With data exhaust, they just monitor specific metrics, like most clicked pages or how quickly users exit after clicking, because everyone clicked the same page and didn't exit immediately. Staff then knew this was the page users actually wanted, so it should rank higher in search results. Companies mastering big data often combine multiple approaches. Let's see how Amazon in the US uses big data to sell books. Amazon was America's first online bookstore. Initially, they hired professional critics to write reviews, using expert recommendations to drive sales. Later, CEO Jeff Bezos envisioned automated book recommendations based on shopping preferences, cost-effective and personalized. This made sense since every Amazon shopper leaves digital footprints, like books purchased, items in abandoned carts, all visible in back-end records. So Amazon started recommending similar items based on past shopping habits. This reused sales data, the first approach we discussed. The results were awful. Recommendations felt repetitive and users ignored them. They pivoted, tracking product correlations instead. Data reintegration, the second approach. Seeking new links in seemingly unrelated data. For example, Hemingway buyers often purchased Dickens too. So Amazon tweaked its recommendation logic. Buying The Old Man and the Sea prompted A Tale of Two Cities recommendations, not Harry Potter. The system didn't know why customers had these preferences. Like, it simply monitored common product pairings and pushed them to readers. This algorithm significantly boosted sales. Amid controversy, Amazon phased out human-curated recommendations. Naturally, Amazon leveraged data exhaust too, collecting user activities like dwell time and review checks, using this data exhaust to improve website design. For instance, if users all linger on a certain page, it must have appealing elements that can inform future designs. Actually, Amazon's entire layout, colors, graphics, and other designs result from repeated testing using data exhaust. With no new tricks left, innovative big data companies emerge. Overall, There are three types of big data companies. First, those upstream in information flow with massive databases like data warehouses. The first type owns data and has advanced processing tech, like consulting firms. The third type possesses big data thinking. Even without data or tech, they spot data's potential value and create monetization ideas. Some companies combine all three, like Google in the US or Alibaba, Baidu, Tencent in China. Notably, in the big data era, these internet giants' edge isn't scale or staff size, it's the massive data from active users. Let's summarize part two. In the information age, data becomes a new gold mine. The same data set can be reused from different angles. With enough creativity, even seemingly useless data holds unexpected value. This is precisely why big data transforms business. Big data companies have emerged, mastering data, analytics, or big data thinking. Professor Viktor believes future success lies in data. It'll be companies' core competitive edge. But every coin has two sides. After painting big data's bright future, Viktor also warns of its dangers. We must watch for three threats: privacy exposure, overprediction, and data worship. First, let's discuss big data's threat to privacy. Typically, companies use user info for specific purposes with consent. Like when we see dense service agreements before using online services, they state how collected data will be used. Companies promise to protect user privacy when using data. But big data tech has massively disrupted this tradition. Because big data has this quirk, unintended efforts often yield surprising results. Many companies don't know data's future uses when obtaining it, so they constantly experiment to mine value, but privacy laws require. The laws mandate that companies must renegotiate agreements when repurposing user data. But for companies, this is time-consuming and nearly impossible. For example, Google used hundreds of millions of search queries to predict flu. Could it ask hundreds of millions for permission? Unlikely. So what to do? Use without permission. Thus, we face a dilemma. On one hand, internet companies provide convenient, personalized services via big data. On the other, every purchase, trip expense, and meal is completely exposed. We leave private info online without knowing how it'll be used. This data might be sold to advertisers for precise targeting. That's why we see tailored ads when browsing, still relatively harmless. But if company data leaks or gets hacked, and criminals access our habits, consequences could be dire. After privacy issues, let's examine big data's second problem: overprediction. Since big data's core function is prediction, can it predict criminal activity? Absolutely. Some U.S. police departments analyzed big data, found crime spikes around certain events, and deployed officers effectively. But using this to predict individual criminality is problematic because it forces group trends onto individuals. This is what Professor Viktor calls overprediction. A University of Pennsylvania professor built a big data model predicting whether released prisoners would reoffend. By inputting massive data like a prisoner's age, crime reason, and sentence length, predictions can be made with up to 75% accuracy. The problem is, suppose someone predicted to commit a crime does indeed commit one. But before he actually acts, can we arrest him based solely on an algorithm? Doing this, though convenient, it essentially punishes someone for something they haven't done. This clearly violates legal principles and could cause wrongful convictions. Besides, if data can precisely predict what people will do we still have real choices? Thus, overprediction fundamentally denies human free will. That said, don't think this is just sci fiction speculation. It's already happening in real life. For instance, insurance actuaries know via big data that men over 50 are more prone to prostate cancer. If you're unlucky enough to be in this group, you pay higher premiums even if cancer-free, which is actually disguised overprediction with less severe consequences. Finally, let's discuss big data's third problem: data worship. Unknowingly, Big data has permeated every aspect of life. In this process, many have become overly reliant on data, even superstitious about analysis results. Even when results defy common sense, like with popular wearables that track sleep quality, these devices record physiological data like heart rate and sleep duration to score sleep, but errors occur, sometimes rating good sleep poorly. Yet many insist data never lies, ignoring their own feelings and obsessing over bad results. Back to our opening case, suppose a critical flu outbreak hits, and health departments must urgently identify affected areas or groups for quarantine. Some might think, since big data offers precise info, why not partner with search engines to isolate people searching flu symptoms? Problem solved? But in reality, this approach is problematic. Due to big data's inherent fuzziness, those quarantined might have just heard a neighbor sneeze and searched flu prevention info, not actually sick. So big data not only fails to help, but creates major headaches. In short, big data's rise brings huge challenges for social governance. When discussing big data, we can't just focus on benefits. Its problems and solutions matter equally. But for better or worse, big data has spread everywhere today, from targeted ads on phones to national policy making. Frankly, big data plays a massive role everywhere, both seen and unseen. As Professor Viktor said, big data's true value is like an iceberg, only a fraction visible, most hidden beneath. With computer tech evolving nonstop, what mind-blowing big data innovations await us? Only time will tell. All right, that wraps up our interpretation of the age of big data. Check show notes below. Until next time.